In this video, we're going to talk about the product and quotient rules for evaluating derivatives. By the end of this lesson, you should be able to answer the following little question. What functions' derivatives can be calculated using the product and quotient rules, and how do we find these derivatives? And as a reminder, by the end of this unit, so by the end of lesson 12, you should be able to answer the following big questions or begin to answer them. We're going to continue these in unit 3, but how do we make finding derivatives easier, and what is the point of finding derivatives? So let's begin with the warm-up. We have find the derivative of f of x is equal to x cubed minus x squared plus 1 times x to the fourth plus x using the power rule. So we can't use the power rule as it stands because notice that we have two functions that are multiplied together. So before we can use the power rule, we need to make sure that we actually carry out this multiplication, and then we'll be able to use the power rule. So to multiply these, we need to FOIL them together. So we'll have, actually the nicest way to do this is to line things up vertically. So we can say x cubed minus x squared plus 1 times x to the fourth plus x. And we multiply these together just like you would your normal multiplication algorithm for regular numbers. So 1 times x is x, negative x squared times x is negative x cubed. X cubed times x is x to the fourth. 1 times x to the fourth is x to the fourth. Negative x squared times x to the fourth is negative x to the sixth. And then x to the fourth times x cubed is x to the seventh. Okay, so we line up those terms that have the same exponent, and then we can just add going down. So we have x to the seventh minus x to the sixth plus 2x to the fourth minus x to the third plus x. Okay, so our multiplication, I'm just going to copy that over here. So we have x to the seventh minus x to the sixth plus 2x to the fourth minus x cubed plus x. And now if we want to take the derivative of this, we can use the power rule on each individual term. So that'll give us 7x to the sixth minus 6x to the fifth plus 8x cubed minus 3x squared plus 1. Okay, so that's our derivative using the power rule. Now we want to find the derivative of f of x is equal to 3 sine of x minus ln of x plus cosine inverse of x. So these are just 3 derivatives from your table in lesson 7. So remember, you should be learning these by now. You're going to be using them throughout this unit. So this derivative is going to be f prime of x is equal to 3 times the cosine of x minus 1 over x minus 1 over the square root of 1 minus x squared. All right, and then finally we have what is a product and what is a quotient. So a product is two things multiplied, and a quotient is two things divided. Okay, so that's our warm-up. Now, let's recall kind of what we've been doing in this unit. So we've seen that the sum of a derivative is the derivative of a sum is the sum of the derivatives. So maybe we conjecture that a product or a quotient might be the derivative of a product is the product of the derivatives, or the derivative of a quotient is the quotient of derivatives. Maybe that's what we think. So we're going to ask that question. So is the derivative of a product slash quotient the product slash quotient of the derivatives? So we're trying to figure out here if the same rule that we had for sums applies to products and quotients. So we're actually going to show that this is not true. And to do that, we're going to look at an example. So find the derivative of f of x is equal to x squared and g of x is equal to x cubed. Then we want to find the product and the quotient of the derivatives. So first I'm going to find f prime. So f prime of x is equal to 2x. G prime of x is equal to 3x squared. Now if I multiply these two, so f prime of x times g prime of x, that's equal to 6x to the third. And if I divide these two, that's equal to 2x over 3x squared, which is 2 over 3x. Okay, now we're going to do the same thing but in the opposite order. So we're going to multiply / divide the two functions first, then we're going to take the derivative. So f of x over g of x, or actually let's do the product first, keep it in the same order. So f of x times g of x is equal to x to the fifth, and then f of x over g of x is equal to 1 over x. Now if we take the derivative of each of these functions, we have that fg prime is equal to 5x to the fourth, and we have f over g prime is equal to negative 1 over x squared. So those are both just done with power rule. So now we want to see, do our answers for multiplying agree with each other, and do our answers for dividing agree with each other? Well, no. So if we look at our answer for f prime of x times g prime of x, that's 6x cubed, that is not the same thing as the derivative of the product. Furthermore, if we look at the quotient of our derivatives, that was 2 over 3x, which is not the same as the derivative of our quotient, which is negative 1 over x squared. So this is really important to note because we're going to have some special rules for dealing with products and quotients that we didn't have to have when dealing with sums. So what does this mean? Well, we found that fg prime is not f prime times g prime, and we found that f divided by g prime is not equal to f prime divided by g prime. So we figured out that these are not going to be as easy as when we did sums and constant multiples. So we're going to need two separate rules for this. So let f and g be two functions. Then the product rule is the following formula. We have the derivative of the product. Oh, I want to do that in yellow. The derivative of a product is equal to the first function times the derivative of the second plus the derivative of the first function times the second. So we normally write this fg prime plus f prime g, assuming that f is the first function, g is the second function. Okay. For quotients, we have what's called the quotient rule. So this one can be a little tricky for people, so I'm going to go over it kind of slow. So we have the derivative of a quotient is equal to the bottom function times the derivative of the top minus the top function times the derivative of the bottom all over the bottom function squared. Okay, so it's important to note that we only use g and f in this particular order because f is on top and g is on bottom. So another way you can remember this is to think of f as high and g as low, and we can rewrite the quotient rule as low d high minus high d low all over low squared. So when I was in school learning the quotient rule, we sang this to the tune of Hi Ho from Snow White and the Seven Dwarves. I'm not going to sing that for you here, but doing that may help you remember the quotient rule. Okay, yeah, so the only reason we use prime notation here in these rules is just to make them more reader friendly, so that way we don't have so many ddx's or dy over dx's floating around. It kind of just simplifies how it looks. I think that's all I want to say there. So let's just dive into some examples. So first, let's find the derivative of r of t is equal to cosine of t times sine of t. So first, we want to break down what rule are we going to need for this problem. And while this one is not super difficult, trust me, it's going to get more difficult as we go and start combining rules. So we practice good habits now. So first, we note that r of t is a product of two functions. So which function should we call f and which should we call g? So f, we're always just going to call the first function, and g is always just going to be our second function. So f here, so f of t is going to be cosine of t, and g of t is going to be sine of t. So we know for our product rule formula, we're going to need the derivative of both of these. So let's go ahead and find those. So f prime of t is equal to negative sine of t. G prime of t is equal to cosine of t. And now we can apply the product rule. So first, we're going to write our formula. So we have f g prime is equal to f g prime plus f prime g. And now we can just substitute in all of our different functions. So we have f is cosine of t, g prime is cosine of t, plus f prime, which is negative sine of t. So I'm going to erase the plus and write a negative. So negative sine of t times g, which is sine of t. Okay, so even though you might want to simplify at this step, that's good. I'm all for you practicing that. However, as far as a test goes, we're not too worried about you going past this second step here. Okay, not right now. But you will need to be familiar with how to do stuff like that in the future. So it's good to practice. But as far as like for graded assignments, I would leave your answers unsimplified to minimize possibility of careless mistakes. Okay, let's look at one more example. So we're going to find the slope of the line tangent to f of x is equal to 2e to the x times ln of x at x is equal to 1. Okay, so we start this by thinking about, well, what does the slope of the tangent line mean? Well, we know that means derivative. All right, we've done that a lot with flashcards and everything else. So by now you should know slope of the tangent line is derivative. Next question we should ask ourselves is f of x a product or a quotient? Well, I have 2e to the x times ln of x, so this is a product. So we know we're going to need product rule. So let's define f and g. So again, as a reminder, f is just the first thing, and g is just the second thing. Okay, so here, f is going to be 2e to the x, and g is going to be ln of x. Now, if we find those derivatives, f prime would just be 2e to the x, and g prime would be 1 over x. So now we just need to apply the correct rule and substitute x equals 1 so that we can actually find the slope of the line tangent, or the tangent line. Okay, so product rule, we have fg prime is equal to fg prime plus f prime g. So if we plug in all of our different functions, f is 2e to the x, g prime is 1 over x, f prime is 2e to the x, and g is ln of x. But now I want to find fg prime of 1. So that means I want to plug in 1 everywhere that I see an x. So that's 2e to the 1 times 1 over 1 plus 2e to the 1 times ln of 1. Okay, now comes just some arithmetic. So 2e to the 1 is just 2e times 1 over 1 is 1 plus 2e times 0. So ln of 1 is equal to 0. And so this term goes away and we're just left with 2e. Okay, notice that I didn't put this 2e into a calculator and get a decimal. So in this course, you want to make sure that you're only getting decimal approximations if it explicitly says 2 in the directions. Otherwise, you want to stick with an exact answer. So that's why we're going to leave e in our answer here. And just as a little side note, since for a lot of you this is the first time you're ever learning about derivatives, My suggestion would be break the process into steps exactly like we're doing. So define your f, define your g, find the derivatives, decide which formula is good, substitute, and simplify. Okay, as you get better, you may be able to start to combine steps. Like maybe you're able to just write out the product rule without explicitly writing down f, g, f prime, and g prime, right? But for now, make sure that you're going through those steps so that you get used to the process before you just try to cram everything into a mental math problem. Okay, let's try another example. This time I think we're going to have quotient rule. So find an expression for the instantaneous rate of change of p of t is equal to 2t squared minus 1 over 2t squared plus 1 in terms of t. So the first thing I notice in this problem is the term instantaneous rate of change. Now, we know from all of the words we've been doing that instantaneous rate of change is the same thing as derivative. So really all this is telling me is I need to find the derivative of that function. The next thing we need to ask ourselves is p of t a product or a quotient? Well, I've got division going on here, so this is definitely a quotient. Okay, so now we define f and g. So as a reminder, for quotients, f, we just take whatever's on top. G, we take whatever's on bottom. Okay, so f here is going to be 2t squared minus 1. G will be 2t squared plus 1. And now if we find each of those derivatives, f prime will be 4t, and g prime will also be 4t. So that won't always happen. That's just a coincidence. Okay, now we apply the correct derivative rule. So our quotient rule, and I'm going to try not to sing the song, but let's see. So we have f over g prime. Okay, I guess I'll do it one time. Okay, so tune of hi-ho, 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 it's off to work we go. So instead of that, sort of change out hi-ho with hi-lo. So it's like hi-lo, hi-lo, it's off to work we go with a low D high minus high D low, hi-ho, 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 hi. Okay, that's it. All right, so you got me to sing it. Great. Okay, so that's our formula. So now what we want to do is actually plug in our functions. Okay, so we have the bottom function, that's g, so we have 2t squared plus 1 times the derivative of the top, which is 4t, minus the top, 2t squared minus 1 times the derivative of the bottom, which is also 4t, all over low squared. So we have g squared is 2t squared plus 1 squared. Okay, so that's our quotient rule. I don't want to simplify this one anymore from here. I'll leave it like that because that's all we're expecting for this test. But keep in mind that in the future you will be expected to simplify. And that's it for the product and quotient rules. So just make sure you complete the check your understanding. And that's the end of lesson 9.